Read and carefully follow the safety instructions in all of your Incra products' owner's manuals. For any cutting operation, always use proper safety equipment such as guards, push blocks, safety glasses, and ear protection. Sbefore performing any cutting operation, carefully think it through. Anticipate any dangerous situations such as grabbing, kickback, splintering, or exposed fingers, and take steps to ensure that they don't happen.
Hello, and welcome to the Incra Workshop. The spectacular new joint that you've just seen is called the Incra Double Box Joint, and we're going to show you how to make it. Believe it or not, this seemingly impossible joint can be easily accomplished once you've mastered the simple Incra techniques that Chris Taylor, the inventor of all of the Incra tools, is going to show you. You are about to learn how just a few basic Incrajig operations can be used to make half-blind and through dovetails, box joints, and much more. Here's a preview of some of the things you'll soon be able to accomplish with the Incrajig.
Box joints add strength and beauty to drawers and boxes. The perfect blend of form and function, dovetails lend an air of fine craftsmanship to any project. The precision and repeatability needed to make projects like this laminated box lid are easily achieved with Incrajig on the table saw. Projects like this cribbage board rely on Incrajig for precise XY positioning.
Now that you've seen what Incrajig can do, let's get started by showing you the basic setup on the router table, one of Incrajig's most useful applications.
The Incrajig is firmly fastened to a 3/4 inch thick hardwood or plywood base. Be sure to use the supplied screws and washers in all 4 mounting slots for maximum holding power. The base should be 6 to 8 inches wide and as long as the width of your table. The entire assembly is secured in place with clamps. Although Incrajig can be mounted directly to the table, you will see that for most applications, the wooden base is preferred. The jig position is indicated by the molded-in reference scale. Sight straight down the back edge of the top half to read it. To obtain the most comfortable visual alignment, loosen the 4 top rack mounting screws and shift slightly in one direction or the other. This is too far to the left, and this is too far to the right. Now we are directly over the mark, and the scale reading is clearly indicated. When you are comfortable with the readout, tighten the clamping knob and then retighten the 4 rack mounting screws. This is the only time you will have to make this adjustment.
Now that we have the jig calibrated to the scale, we must next decide where to put the whole assembly down on the table relative to the bit before we start cutting. Obviously, not just any position will do. You must locate it at some known initial position before you can let the precision of the sawtooth racks take over from there. Fortunately, there are typically only 2 such initial positions, and they're extremely easy to find. One is called the 0 position, and the other is called the center position. First, let's learn how to set the 0 position on the router table.
The 0 initial position is used when you want all of your cuts to be measured from one edge of your board. This is probably the way you are used to working with your old router table fence. First, set the jig to the fully open position with a molded-in scale reading of 0. Now tighten the clamping knob. Make sure that your router is turned off and unplugged. With the back clamp tightened, loosen the front clamp. Tap the assembly towards the bit while sighting along the fence. With each tap, the gap of light between the fence and the outer cutting wing of the bit will get smaller. Continue tapping carefully until one last nudge causes the gap to finally disappear. When this happens, the fence is 0 distance from the bit, and the jig is accurately set to the 0 initial position. Check to make sure that the bit is centered in the fence notch, safely clear of the aluminum on each side. Securely reclamp the base to the table, taking care not to alter your position while clamping. Remember that you set the jig to a scale reading of 0 just before you zeroed the fence. This is now the correct setting, since you have just set the bit to fence distance equal to 0. From now on, whenever the jig is set to a new position, the scale will give you a direct readout of the exact distance between the fence and the bit. This, of course, means that whenever you make a cut, the scale will tell you the exact distance between the edge of the board and the edge of the cut, without having to measure. Now suppose you want to make a groove, say, 1 inch from the edge of a board. Simply set the jig to a scale reading of 1 inch. Place the board against the fence and make your cut. If you want to make more cuts, such as an equally spaced series of grooves, simply move the jig the same distance between each cut. In this case, 3/4 of an inch. As you can see, you can accomplish a great deal of precision cutting in a very short time. It's that easy. And as you can see, each cut is accurate to 1 or 2/1000ths of an inch. Here's a quick review. Set Incrajig to the fully open position with the scale reading 0. Carefully tap the fence towards the bit until the gap of light disappears. Then clamp the jig assembly to the table.
We've just shown you how to zero the Incrajig and thus make the edge of your work the point from which all cuts are referenced. Now we're going to show you how to center the Incrajig and thus make the center of your work the point from which all cuts are referenced. When making joints, one of the most important requirements, besides a perfect fit, is symmetry. You want the joint to be perfectly centered like this one, regardless of the width of the joint. If you can do this and still have both ends come out even, then not only do you have a perfectly fitting joint, but you've also got one that's perfectly centered. We are about to show you how this symmetry and the perfect fit is easily achieved with any joint made with Incrajig. All you have to learn is the one simple technique of setting Incrajig to its center initial position.
In any joint that is perfectly symmetric, one and only one of the cuts will be located in the exact center of the joint. The first step in setting Incrajig to the center initial position is to determine which of the cuts is the one in the middle. In this case, the center cut is right here. Suppose you wanted to make a box joint on a board about this wide. To show you how to get it perfectly centered, we will use as an example the joint shown on page 53 of the Incrajig Handbook and Templates. This is an equally spaced box joint made with a 3/8 inch straight bit. Remember, this is just an example, and the technique can be applied to any joint made with Incrajig. Select the Box 1 template supplied with the Handbook and Templates, and install it in the auxiliary scale slot with the arrow pointing towards the back, away from the fence. First, we have to find the center of the joint. To do this, use a piece of scrap stock that has been cut to the same width as the joint you are about to make, and mark the center of one end of the board. Place the board on the full-sized plans on page 53 and shift it one way or the other until it is centered between two outside pins. The mark on the board now lies atop the center cut, which in this case is 3B. Now set Incrajig to position 3B and tighten the clamping knob. You now have Incrajig set to the position that corresponds to the center cut of the joint. Before continuing, make sure the router is turned off and unplugged. The next step is to locate the jig assembly on the table at a position such that with the jig set to 3B and the board against the fence, the center mark is aligned near the center of the bit. Clamp the rear of the assembly to the table. Do not tighten the front clamp at this time. Carefully tap the assembly over until the center mark on the board is directly over the center of the bit. In other words, when the jig is set for making the center cut, in this case cut 3B, you want the center of the board over the center of the bit. Now tighten the front clamp, taking care not to alter the position of the jig assembly. And as always, make sure that the bit is safely centered in the fence notch. Often, if you have made a good visual alignment of the mark over the center of the bit, you will now be perfectly centered and you can stop here. If not, then one further quick step will ensure that your joint will come out perfectly symmetric. Raise the bit about 1/8 inch above the table. And using a rubber-soled push block, make a single groove down the middle of the board. Then, flip the board around and make a second cut down the center. Remember, the jig is still set to position 3B. With the router unplugged, set the board on the table with the bit located inside the front of the groove. Notice that the groove is just slightly wider than the bit. This is because our initial alignment of the mark over the bit was off by just a small amount, causing the groove to be widened slightly on the second pass. One minor correction is now all that is needed to get perfectly centered. Loosen the front clamp, but leave the rear clamp tightened. Now carefully tap the assembly over until the bit is perfectly centered in the groove. Finally, tighten the front clamp and you are perfectly centered. Now let's have a quick review. Mark the center of the board. Place the board on the full-sized plans and center it. Determine the center cut of the joint. Install the desired template. Set Incrajig to this center position. Now place the jig assembly on the table so that it positions the center of the board over the center of the bit. Make a cut down the center of the board. Leaving the jig setting unchanged, flip the board around and make a second cut. Tap over the jig assembly until the bit is centered in the groove. You now have Incrajig set to the center initial position.
Now that you know how to center your work, let's apply this technique towards making something practical, such as a complete box joint drawer.
Here are the front, the back, and the two sides of the drawer that we are about to make. Each board has already been carefully cut to size. Keep in mind that no matter what kind of tool you use to make a woodworking joint, you won't be completely successful unless the boards that you start out with are square and accurately surfaced and dimensioned. These boards are the same width as the sample that we just used to demonstrate how to center your work. Since we will also be using the same Box 1 plan and template, we are already centered and ready to go. Box joints usually look well proportioned when the thickness of the boards is about the same as the width of the fingers in the grooves. We are using a 3/8 inch straight bit to cut the joint, so the boards have been surfaced to the same thickness as the bit, 3/8 of an inch. The depth of cut should be just slightly greater than the thickness of the boards. The procedure for setting the depth is very simple. Just lay one of the boards on the router table and raise the bit until it is just barely higher than the top surface. That's all there is to it. Now that the work is centered and the bit depth is set, we are ready to put the boards on the right angle fixture. Here we are using the Incra right angle fixture. Notice that we are using a spring clamp to securely hold the guide hook against the fence. This holds the fixture in place, leaving both hands free to clamp the boards. Here is a little time saver that can be used when cutting equally spaced box joints. If the two halves are offset from each other by the width of the bit, we can cut both pieces at the same time. Keep in mind that this will only work for equally spaced joints. Here we are using a 3/8 inch thick board as a spacer to provide the offset. Use the same 3/8 inch thick spacer to offset the two halves of the joint before clamping them to the right angle fixture. We are using both a fronting and backing board to prevent tear out. Make sure that the bottoms of the boards are flat against the table and the sides are firmly against the fence. Now, let's start cutting the joint. Since the first cut is an open one, you should start with a light scoring pass to prevent splintering. Notice that we are using a negative fence setting for the first few cuts, in which some part of the bit is actually inside the notch. Work your way towards position 1B, moving 1/16 to 1/8 of an inch closer on each cut. This is a good technique to use whenever making outside cuts such as this. After completing cut 1B, move the jig to position 2B, 3B, etc. for each successive cut. The template positions the jig exactly 3/4 of an inch between passes, 3/8 of an inch for the pin, plus 3/8 of an inch for the groove. Remember that we can skip the A series of cuts because we have offset the front and the back of the drawer from the two sides by the width of the bit, allowing both series of cuts to be made at the same time. Of course, the two halves can also be made separately if you do not use the offset. Now, unclamp the boards, flip them over, and reposition them on the right angle fixture. Then clamp them securely, just as you did for the first half of the drawer. Now complete the second half in the same way you did the first half, using the same B series of cuts. Remove the completed drawer sides from the right angle fixture and assemble for a perfect fit. It really is just as easy as it looks. Now for a quick review. Center your work. Set the depth of cut. Clamp the boards to the right angle fixture. Set Incrajig to the template settings. And make your cuts.
Most woodworkers will probably agree that the dovetail joint has come to be accepted as one of the hallmarks of fine craftsmanship. It's the perfect blend of beauty, strength, and durability. Dovetails in a finished project make an eloquent statement of the pride and quality that went into building it.
Before we show you how to make dovetails with Incrajig, let's first talk a little about dovetail terminology. This is the half-blind dovetail, which we are about to make. Later, we will show you how to make sliding and through dovetails. It seems that one of the most difficult aspects of making dovetails is trying to remember which half are the tails and which half are the pins. These are the tails, and these are the pins. It's called a half-blind dovetail because the pins are limited in length by what is known as a blind cut. Craftsmen traditionally hid their joinery from sight. Today, this beautiful workmanship is often designed to be proudly displayed in boxes, furniture, and casework. The tails are always cut with the board perpendicular to the table, with the bit passing all the way through the end of the board. The pins are always held flat against the table, with the bit cutting straight into the end grain. The pin cuts are always limited to a fixed length, which is determined by the thickness of the tails. Notice that we have cut a dovetail-shaped rabbet in the back of the tails. This provides the relief necessary to cover up the rounded ends of the pin cuts when the tails are fitted into them. If we didn't cut the rabbet, you can see that the ends of the pin cuts would still be visible. That's the only purpose of the rabbet, to cover the rounded ends of the pins. The length of the pin cuts, and not the rabbet in the tails, determines how far the tails fit into the pins. When the length is just right, the face of the tails will be flush with the end of the pins. If the length of the pin cuts were too short, the face of the tails would stick out beyond the ends of the pins. In a moment, we will show you a very simple procedure for adjusting the length of the pin cuts to just the right amount. The most important thing to learn about making dovetails is how to get a perfect fit. Accurate spacing between cuts is obviously critical, but just as important is the correct depth of cut. Incrajig will easily ensure that your spacing is perfect. But as with any other dovetail jig, the correct depth of cut must be arrived at through a little trial and error. There is no limit to the type of dovetails that you can make with Incrajig. The official Incrajig handbook has plans and templates for making a large selection of them. We are going to make a drawer which is joined together with the equally spaced half-blind dovetail shown on page 62. This joint uses a 14-degree, 1/2 inch bit. It is made with the template labeled Dove 1. The procedures for making any other half-blind dovetail, regardless of bit size and cut spacing, are identical to the ones we are about to show you. Here are the boards which will soon become the 4 sides of the drawer we are about to make. As always, the stock is accurately surfaced and cut to size. Like any other joint made with Incrajig, the first step is to set the center initial position to ensure that it is symmetrical. We have already shown you how to center a box joint, and except for the different bit, the procedure is the same for the dovetail. Here's a quick review. Install the template, in this case, Dove 1. Mark the center of a test board cut to the same width as the finished joint. Place the board on the full-sized plans and find the cut that belongs in the center of the joint. In this case, it's 2A. Set the jig to this position. Tap the jig unit over until the center of the board is aligned with the center of the bit. With a good eye and a little practice, this will get you perfectly centered. If you want to be sure, perform this one simple extra step. Make sure that the jig is set to the center position, in this case 2A. Then, with the bit set to a shallow depth, make a cut down the center of your test piece. Flip it around and make a second cut. As you can see, the bit is now perfectly centered in the groove, and no further adjustment is needed. Now securely clamp the unit to the table, and you're ready for the next step, setting the depth of cut. Set the bit to the depth of cut shown on the plans in the handbook. For the joint we are making, Dove 1, this initial depth should be 5/16 of an inch. Remember that this is an approximate setting that will get you close. The procedure for finding the optimum depth is simply a matter of making a few trial cuts, testing the fit, and then either raising or lowering the bit by a small amount to close in on the exact depth. The shallower the cut, the looser the fit. On the other hand, the deeper the cut, the tighter the fit. Or to put it another way, if the joint is too tight, lower the bit to decrease the depth of cut. If the fit is too loose, raise the bit to increase the depth of cut. Just remember this: heighten to tighten, lower to loosen. We are going to make a few trial cuts in some scrap stock clamped to the right angle fixture. The first few cuts will be light passes, working your way towards position 1B. The first of these passes scores the edge of the boards to prevent splintering on later cuts. It is generally good router table technique to complete open, outside cuts, such as this, in several easy side-by-side passes, rather than one heavy pass. It may take a bit more time, but the results are well worth it. Now make several more cuts at the B positions marked on the template. After removing the boards from the fixture, see how they fit together. If the fit is too loose, as we have intentionally made this one, the bit depth is too shallow. To make it tighter, raise the bit by slightly less than half the width of this gap. Since the joint is too loose, heighten to tighten. As you can see, we have just barely raised the bit. With the bit set to the new depth, flip the test pieces over, put them back on the fixture, and make a new set of trial cuts at the other end. And check the results. As you can see, the small amount that we raised the bit, or heightened to tighten, resulted in a perfect fit. You may want to mark and save a sample made at the correct depth of cut. From then on, you can instantly set the bit to the exact depth by using this sample as a template. We now have the bit set to the cutting depth that will be used for every single cut on both the pins and the tails of not only the half-blind dovetails that we are about to make, but also the sliding and through dovetails that we will show you later. No further adjustments of any kind will be needed. The rest is pretty much a matter of setting the jig to the template marks and making the cuts. Remember, we showed you that a rabbet is needed in the back of the tails to cover up the rounded ends of the pin cuts. The rabbet is the first part of the joint to cut. First, we will lightly score the sides of the boards to prevent possible tear out when the rabbet is cut. Next, place the back of the board against the fence and make a light scoring pass. Use a push block. As you can see, we have made a very shallow cut to sever the wood fibers, which will prevent splintering on the next heavier cut. Move the jig backwards by an amount equal to the desired width of the rabbet and make the final cuts. For this particular dovetail, the rabbet width is 5/32 of an inch, as indicated in the plans on page 63 of the handbook. If you aren't using the handbook, a good rule of thumb is that the width of the rabbet should be about 1/2 the depth of the cut. With the drawer sides clamped to the right angle fixture, we are now ready to cut the tails. Since cut 1B is an open cut, it is made in several light side-by-side passes. Notice that the boards are oriented face to face. This will prevent tear out from occurring on the cosmetic side of the joint. Also, if you are making several drawers, you can clamp as many boards as you like to the right angle fixture to cut all the tails at one time. As you can see, we are making our cuts at the B series of template marks. Notice that the bit height is unchanged from the depth of cut that was used for making the rabbet. As we mentioned earlier, all cuts in the joint are made at the same depth. Next, flip the boards over and re-clamp them to the right angle fixture. Take care to ensure that the bottoms of the boards are flat against the table and that the edges are firmly against the fence. Complete the other half of the tails by making an identical series of cuts on this end of the boards. Now we are ready to make the pins. The length of the pin cuts determines how far the tails can go in for a perfect fit. This dimension is controlled by the Incrajig stop on the outfeed side of the fence. To position it, first, place the board against the infeed side of the bit. Run the stop up against the front edge of the board and clamp to the fence. Now set the sliding scale to a reading of 0. The scale that you see on the left is used with an optional second Incra stop, which we will show you a little later. Be sure that the nylon stop screw safely clears the top of the bit. Now move the stop backwards, away from the bit, by an amount equal to roughly the thickness of the tail boards, which in this case is ½ inch. This will usually result in a length of cut that is just a little too short. Using a push block, make a trial set of pin cuts in a piece of scrap stock that has been cut to size. Use the A series of template marks. As we just mentioned, the length of the trial cuts was intentionally made a little too short. As a result, the tails will not fit all the way inside. The amount by which they stick out is the distance that the stop must be moved farther away from the bit for a perfect fit. Here it looks like we need to move it about another 1/16 of an inch. So move the stop back by this amount. And make another set of cuts at the same positions to lengthen the original cuts by the small distance that you just moved the stop backwards. As you can see, the length is now just right. When using this method of setting the stop to the correct position, you should always try to make your initial cut just a little too short, as we did on our first set of trial cuts. This makes it easy to see how much further you need to go and allows you to use the same board for both the first and second set of test cuts. If some further small adjustment is still needed, you can fine-tune the remaining distance by turning the stop screw a small amount in the appropriate direction. Now that the stop is positioned correctly, complete the pins by setting Incrajig to the pin or A marks on the template and quickly making the cuts. Use a push block for safety. As you can see, the drawer fits together perfectly. Remember, the techniques we showed you for making this half-blind dovetail will work for any other half-blind dovetail, whether equally or variably spaced, using any other dovetail bit. Now, let's have a quick review. Set the depth of cut. Cut the rabbet. Cut the tails. And cut the pins. Now that you have mastered half-blind dovetails, let's make a quick set of sliding dovetails. Here we are making the B half of the sliding joint. As always, the first open cut is made in several light passes to prevent splintering. As we mentioned earlier, all types of dovetails made with a particular bit use the same depth of cut. The bit height is thus unchanged from the setting that we just used on the half-blind dovetails. Simply set Incrajig to the same template marks that you used before, and use a push block to move the wood over the bit. The sliding dovetail is completed by making the A series of cuts in the second half. As expected, we have a perfect fit. We are now going to show you a new method for making through dovetails with Incrajig that seems almost too good to be true. All of the cuts are made with just one basic setup, using just one dovetail bit. As a matter of fact, it uses exactly the same setup and procedures that we just used for making half-blind and sliding dovetails. And unlike any other router-made through dovetails, it is not necessary to switch between a dovetail bit and a straight bit, because the straight bit is not needed. This means that all of the tedious recalibration involved in changing bits is totally unnecessary. Here again is the half-blind dovetail that we just made. Let's see how it compares with a through dovetail. Imagine planing down the surface of this pin board until the tails started showing through the sides. If you did that, you would have changed this half-blind dovetail into a through dovetail. The cut spacing would still be the same, and the depth of cut would still be the same. The only difference is that the pin board would now be thinner than the depth of cut. Here are through dovetail pins that have already been made. As you can see, the depth of cut is just slightly greater than the board thickness. In other words, the top of the bit cuts all the way through the top of the board. The tails should also be the same thickness as the pins. This ensures that the pins project through the tails and the tails project through the pins. Remember that since the bit depth controls the fit, you cannot raise the bit to project above the boards. You must instead reduce the thickness of the boards to make them thinner than the depth of cut. The tails for both through and half-blind dovetails are made in almost exactly the same way. The only difference is that through tails do not need the rabbet in the back, while half-blind tails do. Now, let's make the tails. Clamp the tail boards to the right angle fixture. Set Incrajig on the B series of marks and make the cuts. Use the same bit, the same depth of cut, the same template, and exactly the same setup that we just used for making half-blind and sliding dovetails. Remember that the rabbet is not needed, and the boards are just slightly thinner than the depth of cut. As always, we are using both a fronting and a backing board to prevent tear-out. The pins are made in two steps. The first step is identical to the tail making procedure that we just showed you, with the one exception that you use the A or pin series of cuts instead of the B or tail series of cuts. So clamp the pin boards to the right angle fixture and make your cuts. Just like the tails, you can cut more than one board at a time. Again, the board we are cutting is placed between a fronting and backing board to prevent tear-out. The second step is almost identical to the procedure for making half-blind dovetail pins. Run the end of one of the pin cuts that you just made up against the front edge of the bit. Then set the stop screw against the end of the board and clamp the Incrastop to the fence. Notice that we have clipped off the head of the nylon stop screw to prevent the bit from making contact with it. Now set Incrajig to the same A series of pin marks on the template that you just used and push the board into the bit with the stop limiting the length of cut exactly as you did for half-blind dovetails. Notice the small tabs left on the pins that prevent the tails from fitting all the way in. These tabs are easily shaved off with a sharp pocket knife. Once the tabs are gone, the joint fits together perfectly. On joints using larger dovetail bits, the leftover tab is relatively smaller and can often be left intact, actually locking the joint in place for a perfect fit.
The router table is by no means the only tool in your shop that will be greatly improved by putting an Incrajig on it. Here's an example of the extraordinary work that can be accomplished with Incrajig on the table saw. As you might expect, a great deal of precision cutting and repeatability went into making this laminated box lid. We are now going to show you the setup procedure that makes this kind of table saw accuracy possible.
Here we have Incrajig ready to go to work on the table saw. This arrangement is very similar to the setup we have already shown you on the router table. To zero Incrajig to the blade, first turn off and unplug the saw. Set the jig to the fully opened 8-inch position. Place the fence flush with the blade to get it parallel, and securely clamp the unit to the table. The blade guard should be put back in place before cutting. Now, whenever you set Incrajig to a new position, the molded-in reference scale will give you a direct readout of the exact distance between the fence and the blade. Here we have it set to exactly 4 inches. Now make the cut. Be sure to follow all normal table saw safety procedures. As you can see, we have cut the board to exactly 4.000 inches. The drill press is another tool that is greatly enhanced when used with an Incrajig. Here we have it set up as a precision XY positioner. The jig is mounted to a base plate, which is clamped to an auxiliary table. The angle of the fence relative to the edge of the table is not important since the bit is circular. The initial setup for this application is simple. Set the jig to the fully opened position where the scale reads 8 inches on one side and 0 inches on the other. Like most other Incrajig applications, we will use the side of the scale that reads 0. Now close the jig by a distance equal to the radius, or half the diameter, of the drill bit. Here we are using a 1/2 inch diameter bit, so we have set the jig to a scale reading of 1/4 inch. Now tap the unit over until the bit is just kissing the fence, and then clamp to the table. The center of our 1/2 inch bit is now exactly 1/4 of an inch away from the fence. Since the scale also reads 1/4 of an inch at this position, the reading at any other setting will always give us a direct readout of the distance between the fence and the center of the bit, and thus between the edge of a board and the center of the hole to be drilled. If, for example, we wanted to make a hole exactly 2 inches from the edge of a board, simply set the jig to a scale reading of 2 inches and drill the hole. We can add a second axis of precision positioning control to this arrangement by simply putting an Incrastop on the right side of the fence. Incrastop's position is controlled by the same precision cast sawtooth racks that are used in Incrajig. Here's how to zero Incrastop to the edge of the board. With the bit lowered to the table, place a board against the left side of the bit. Position the Incrastop as close as possible to the edge of the board and tighten the clamping knob. Unscrew the stop screw a fraction of a turn, just enough to put it in contact with the edge of the board. Slide the 1/32 inch scale into place with the 0 end toward the center of the fence. Carefully position the scale to a reading of minus the bit radius. The minus direction is to the left side of the 0 mark. Now, for every Incrastop position, the scale on top of the fence will give you a direct readout of the exact distance between the end of the board and the center of each hole to be drilled. Now that you have both X and Y axis positioning control, projects such as this cribbage board can be accomplished quickly and easily without having to measure. Throughout this video, you have already seen the Incrastop in action. We used it for controlling the length of the pin cuts on half-blind dovetails, and you just saw it being used as an XY positioner on the drill press. Here is another use. With Incrastop's precision and ease of operation, you can quickly and accurately control the length and spacing of stopped cuts. Imagine how useful this capability would be for making hinge mortises. Like most other Incra applications, the first step is to set your initial position. Here we are going to zero Incrastop to the router bit in the same way that we zeroed it to the drill bit on the drill press. Place the front end of the board against the router bit. Position Incrastop with the stop screw against the end of the board and tighten the clamping knob. Slide the 1/32 inch scale in the slot on top of the fence. The zero end should be towards the center. We are now zeroed with the bit to board distance equal to 0. Now if you want to make a slot, say 1 inch long, set the stop to a setting of 1 inch and make the cut. It will be exactly 1 inch long. If you want to make more cuts, simply set Incrastop to the new setting and let the stop screw precisely control the length. Incrastop controls the length of the cut, and Incrajig controls the position relative to the edge of the board. As you can see, it's easy to put your cuts exactly where you want them. By putting a second, optional Incrastop on the other end of the fence, you gain the ability to precisely control the start of a cut as well as the end. This is useful for cutting multiple slots or mortises such as these. The front Incrastop controls the end of the cut, while the back one controls the start of the cut. Now by setting both stops to the desired scale readings, you can easily control both the length and spacing of any series of slots or mortises without having to measure. Carefully lower the board onto the bit while moving it back and forth between the two stops. Be sure that your fingers are always well clear of the bit. Also, keep your cuts shallow. To achieve greater depths, make your mortises in several steps, raising the bit slightly on each pass. Because of Incrastop's accurate repeatability, this is easily accomplished. For longer boards, you can extend the stopping range by clamping a stop block to the extender bar. Here we are using a second optional extender bar, in addition to the one supplied with the fence system. This arrangement controls both the start and the stop of a long closed mortise. If you've ever had the need to position a stop block beyond the end of your fence, you will know just how useful these extender bars can be. How else would you make a long mortise such as this?
We are now going to show you how to make a fascinating new joint, which to our knowledge can only be made with the Incrajig. It takes a basic box joint and adds at least 2 extra visual dimensions. For that reason, we call it the Incra double box joint. Here, it is the focal point of this beautiful and unique jewelry box. As you will see, this seemingly impossible joint can be made by combining just a few of the basic operations that you've already learned.
Here are the 4 parts that make up the joint. We call it a double box joint because these 2 parts fit together to make one double joint, and these 2 parts make the other double joint. When the 2 halves are put together like this, you now have a double box joint. All cuts are made with a 3/8 inch straight bit and are 3/8 of an inch deep. The boards are also 3/8 of an inch thick. For reasons that we will explain in a moment, the center trim pieces come from boards that are about 1/2 inch thick. The actual width of the joint can vary anywhere from 1 1/2 to 7 1/8 inches. Here is the double box joint plan and templates supplied with this video. We have found that the joint works best visually when it starts and ends on one of the pins shown on this A-series part of the drawing. For that reason, we recommend that you make your joint close to one of these widths. The joint we are now going to make will be 2 5/8 inches wide. As you can see, there are 6 different series of cuts needed to make this joint. The top half, which is controlled by template 1, consists of series A, B, and C. The bottom half uses template 2 for cutting series D, E, and F. While cutting the joint, you will need to switch back and forth between the two templates. To install the templates, first cut off 2 1/2 by 1/2 inch squares of the two-sided adhesive supplied with the video, and attach one to each end of template 1. For now, remove the paper backing from the arrow end only. To install template 1, first set Incrajig to a molded-in scale reading of 4 9/16 inches on the inside scale. Slide the end labeled 1 under the top half until it is aligned on position 6A. Then press the arrow end of the template into place. Be careful not to alter the template's position as you do this. Now remove the top half of the jig. Peel off the paper backing on the other end of the template and press into place. Template 2 is installed on top of template 1. To ensure that both are aligned with each other, you must set Incrajig to a different position before installing template 2. Set Incrajig to a molded-in scale reading of 4 3/8 inches. With the paper backing on the arrow end peeled off, slide template 2 under the top half until it reads 7F. Then press into place. Since only one template at a time can be used, simply remove template 2 when you need to switch back to template 1. Like most joints made with Incrajig, the next step is to center your work. Mark the center of the board and place it on the full-scale plans. Our board is 2 5/8 inches wide. And as you can see, the center cut for this width is at position 2B. Set the jig to position 2B. Tap the jig over to align the center of the board over the center of the bit. Then clamp to the table. As we mentioned earlier, our boards are 3/8 of an inch thick, which means that a good depth of cut is also 3/8 of an inch. Using the board as a gauge, set the top of the bit just barely higher than the top of the board. You might want to look at the plans for this joint as you follow our progress. Now that the work is centered and the depth of cut is set, we can start cutting. First, we make the A series of cuts with the boards perpendicular to the table on the right angle fixture. Notice that the wider grooves are achieved by making intermediate cuts between 1A and 2A and between 3A and 4A. If you have a powerful router, you might be able to skip these middle cuts, but they only take a few extra seconds and they make the job a lot easier. We recommend that whenever possible, you make several light side-by-side passes rather than one heavy, wide pass. Next, we can make the trim pieces, which later will mate with the A cuts that we just made. Start with a board that is exactly the same width as the joint and 4 or 5 inches long. Route grooves down the length of the board using the B series of template marks. All cutting is done from outside to inside to give maximum strength in the part of the board that bears against the fence. Pay careful attention to the direction in which the board is moved relative to the bit. The open, outside cut at 3B is made by pulling the board towards you, against the rotation of the bit to prevent grabbing. This cut should be completed in several side-by-side passes, no more than about 1/16 of an inch apart. All other cuts are made by pushing the board forward, away from you. Since 1B is another open cut, it is also made in several light side-by-side passes. When this piece is completed, we will then cut it into slices. Here is one slice that has already been cut. It will be glued to the A board like this. Notice that the C cuts have not yet been made. The area above the top of the cut should be no less than about 1/8 of an inch thick. When added to the 3/8 inch depth of cut, the total board thickness is about 1/2 inch. When we slice up the center section, we need to find a way to prevent splintering as the blade enters each groove. This is easily accomplished by filling up the B grooves with a mating board in which the A grooves have been cut. To make the slices, place the 2 mated boards on the table saw with the trim piece, or B board, on the bottom. Then raise the blade until it is just high enough to cut through it, but well below the top of the A board. To set the fence to blade distance, use a side of the joint as a gauge. Here we are setting the distance about 1/16 inch more than the thickness of the side. This extra width will later be sanded flush after the glue is dry. A second trim board should be made and used to push the first trim board against the fence. Place the A board on top and use a rubber-soled push block to cut off the first slice. Be sure to use good side pressure to prevent the board from twisting away from the fence as you cut. After the saw blade has stopped, remove the slice that you just cut and set it aside. Slide the bottom trim boards firmly against the fence and make the next slice. The outside trim board maintains support under the A board as the inside trim board is sliced away. Now glue the B trim slices to the A board. Each B slice should be just slightly wider than the side of the joint to which it will be glued. This extra width will later be sanded flush after the glue is dry. After the glue has dried and the boards have been sanded smooth, put them back up on the right angle fixture and make the final series of C cuts between the A pins. Be sure that the sides of the boards are flat against the fence and the bottoms are flush with the table. Here is how the completed joint fits together. We have shown you how to make the half of the joint which uses template 1 to make the A, B, and C series of cuts. The second half uses template 2 to make the D, E, and F series of cuts, using exactly the same procedures that were used for making the first half. When both sides are completed, the joint fits together perfectly like this. That's all there is to it.
These are just a few of the unlimited new woodworking possibilities the Incra tools will bring to your shop. Once you've mastered the techniques we've shown you today, you're well on your way to creating your own. Ideas that were previously locked up only in your imagination can now be readily accomplished. You've seen some amazing things that we've made with Incrajig, and now we'd like to hear from you. If you have an interesting project that you've made with Incrajig, or would like more information on any of the Incra tools, please contact us at Taylor Design Group, Post Office Box 810262, Dallas, Texas 75381.
Incrajig and the other Incra precision tools will bring unlimited new woodworking capabilities to your shop. Much more than just a dovetail and box joint jig, Incrajig serves as a precision incremental fence or variable stop block on virtually any stationary woodworking tool in your shop. The Incrajig handbook and templates features 17 pre-marked templates and full-sized plans for making a wide selection of box joints, dovetails, and Incra double dovetails with possibilities for hundreds of beautiful variations. Incragage will greatly increase the accuracy of all of your layout, setup, and marking jobs, while it dramatically reduces the time and effort taken to get them done. It works as a freestanding depth of cut gauge, a precision marking gauge, a fence alignment gauge, and a center finder. The Incra fence system, featuring the patented Incra stop and the optional right angle fixture, add a whole new dimension to Incrajig's already impressive capabilities.